Okay, so you should have already had page 9R set up. You should have your foldable ready. So what this is asking you to do is, you are driving down the road at 50 miles per hour. What forces are present? What has inertia? So you have two objects that we're really looking at. We have the vehicle and we have the person. All right, so on this, both the car and person have inertia. And are moving at the same speed, velocity, because they're going the same speed in the same direction. All right, so both these objects have inertia. So when you hit the brakes, you suddenly slam on the brakes to avoid a deer. Explain what happens to your body and why. Why do we wear seatbelts? All right, so what's happening here is the same thing that happened to the car with the washers on top. The car hit something or something caused the car to stop, but because this is a separate object in the vehicle, the person or the washers were a separate object in the vehicle, they're going to continue forward at the same speed until something restrains or something stops them. For instance, the seatbelt. Okay, so this part right here, the seatbelt provides the opposing or stopping force. Guys, the only kind of forces that can stop motion are going to be those forces that act in the opposite direction. So it's going to be the forces acting in the opposite direction. So the seatbelt is actually right here. So go ahead and sketch these arrows with me. That's the force of the seatbelt, and this is the force of the person. All right, remember, we're trying to cancel it out so that this person does not get injured. All right, we want the person to stop with the car. That's why you have the seatbelt. All right, so I'm going to flip this up one more time. I'm going to give you guys about 30 seconds to finish getting this written. All right, key pieces of information in this. All right, when the car stops, the person will continue to move at the same velocity. The seatbelt provides the opposing force. All right, make sure you're underlining what I'm underlining. Okay, once that's done, you're going to slide to the bottom of the page, and we're going to actually go ahead and state Newton's law. Right, Newton's first law, the law of inertia. Guys, I'm making unbalanced force completely capital for a reason. The only way that you're going to be able to get an object to move that is at rest is if you apply an unbalanced force. We talked about unbalanced forces before we even started this. Right? Unbalanced forces are going to be those forces that cause an object to change their motion. So if it's stationary, it's going to cause it to move. If it's moving, it's going to cause it to do one of three things. Remember, we're going to speed up, slow down, change direction, or the other two, stop or start. All right, again, I'm capitalizing unbalanced forces. This is going to be more about the objects that are already in motion. Right? The objects are going to continue to move at a constant speed, and that means the exact same speed in the exact same direction until acted on by an unbalanced force. Guys, that means they have the exact same inertia and no acceleration is happening. The only way acceleration can happen is if we have an unbalanced force. Right? I'm going to open this back up, make sure everyone has everything. I'm going to give you guys about 20 more seconds.